Hello friends, I am Mani and today I am going to discuss some prestigious model like a moving average model. Most of the time you see in the financial market and it's a really very reputed model and we are using in the financial market like how to forecast a stock price index. So moving MA models like it's a short form for the moving average model and it is a second important building block in univariate time series. So first AR model I think I have already downloaded means already put this video, otherwise I can put here AR model also, don't worry. And so this is the second and it is a building block that it is a most of the time we used as a part of the more complex time series. It can also use as a standalone. So AR just previous we have discussed like auto regressions and this is the MA as a moving average. After some time we will discuss AR MA combined of AR MA models, and in the future if I get time then we can also uh, analyze like ARIMA, SRIMA and SARIMAX models also. Okay, so many numbers of the models, but these are the very prestigious models and try to the understand. So first we want to see how the model applied. This model is applied to forecasting and I will take one example. So like in the AR model just we have already discussed, the model is optimized as a stand-alone model and this is also just when the applying the univariate time series in practice we will generally use SRIMA and SRI max model directly, but after all MA model is a component of this model. So this is really helpful first if you are not able to understand ARMA. So I think you may get a difficulties. So yes, there is the added the value in the seeing the MA model applied separately, and it's important to the understand building block for SRI MX model. So let's see just as a mathematical way, mathematical model like a MA model is a very like that the AR model, but it is a very different in intuitive understanding where the AR model looks at a lagged value. I did discuss of the target variables to predict the futures, and in an MA model looks like a model error of the past predictions. This is the very interesting here. So the model defined like a xt. If you write like a xt, capital XT, so xt are the current value unlagged. This is called unlagged, and I am going to the right like a mu plus et and plus theta 1 eta t minus 1 and dot 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 till like a theta q e t minus q. So xt just I told you xt are the current value, mu is like an average, you could say like you can say average of the series, you can also say like a mean, e like a epsilon, it is the error terms of the model, and theta are the coefficient to a multiplier with the each of the past value. Number of times I have discussed like in the regressions model also. So as you can see, the model has only the past error in it and no past value. So this means that to predict the future, if you don't look at what happened in the past, but only at the how wrong you were on the past. So let's see, I have already discussed these things, don't worry. So let's see, in this model, the model has only the past error and in it has no past value. So both AR model and MA model would be able to take this drop, this account over a time, but in the different ways. The AR model it has the past low value, and the MA model would model it as a larger error, so which can be interpreted as a large impulses. So in this case, it makes a sense to see the error as the impulses rather than the value itself, because the fact that the impulses was unexpected is what is going to be a driver for the stock price the next day, as a stock traders will be the recast to this unexpected impulses. So first, let's see, the first I am going to the collect data. Fitting the MM model is the more complicated than the AR model. Excuse me, sorry. And from the high level, the MM model seems relatively comparable to an AR model. So MA dependent in the past error. So if there is the big differences here when fitting the MA model, you don't have the past error of the model. And one more thing, just there is some sort of the circular dependency here, which makes it impossible to find a straightforward methods to fit the model at once. So it different techniques can be used for fitting in a MA model, which is the most common and non-linear least square. So assume that the error at a time like a 0 is negligible, and the thetas can then be estimated and using some formula theta cap and analyze like a argument minimum, and it will start like a t will equal to 2t capital T and summations. Now bracket start xt minus theta sin sigma k will start to 0 until t minus 2, and bracket start minus theta to the power k, and epsilon like you can like t minus 1 minus k whole square. So since this formula is used the argu minimums, and it is the numerical search for the optimal value for theta, this means that fitting the model is simply done by iteratively searching through a different value for theta and identifying which value for theta lead to the lowest value. So first just I have already need to the collecting a data from the Yahoo Finance. So need to the some import the some specific model like pandas, import pandas as a pd, import numpy as a numpy, import Yahoo Finance because I am going to the collect here the data from Yahoo Finance. Cborn sci stats.scs stats model.api ASM import stats model dot time series analysis API dot SMT, import matplot dot pyplot as PLT, date times imported date, and from a stats model TSA halt winters don't need here, because after some time we will use halt winters and import here specific. After that, just I am collecting a data like one of the company is the most prestigious company. It is in India, like a Reliance, and I am collecting a data till today, because this video is making like in night, so the 12th January 2023. Let's see the we could see here the your data head and what is doing this data. So your price is moving this way. So first we need to see in this data, this is the important like MA models, also the absolute need for the stationarity. So where the AR model can adapt is the non-stationarity situations, but MA model cannot. So MA model needs to the stationarity. So the augmented Dickey-Fuller test and differentiations are notions that have been covered in this. So first choosing between the AR and MA model. So first we try to understand which model we have to the select. So AR model, the lag of the MA model can be decided by looking at the PACF, like a partial autocorrelation functions we will plot, and but there is a more used like a PACF curve, and then just selecting the best theoretical lag. So PACF plot can also help you to choose a correct type of model. For instance, you have now seen the AR and MA model, but you have no idea which one to use. So the type of autocorrelations can be a factor in these decisions. So let's see the following just indicators and the type of the model we will use. First, autocorrelations, PACF we will plot, and autocorrelations decay to zero. This is the indicator. Autocorrelation decay exponentially, second way, and third autocorrelations alternates between positive and negative and decay zero. So let's see, just I have plotted and simple logs I have already plotted. So and then log returns I have been plotted, simple and log returns and dot tail we could see here my price, and another the DF, the simple return log return we can plot here, but we are not able to the clarify. But now let's see the just I am taking a closing price, and now I am going to the plot here the individual closing price data like C. So if I have plotted this data, is it stationary and not stationary? So I told you there are two ways, one is the augmented and another is the differentiations. So if you are going and to like a plot this way, so you could see that it's a variability, like you can sometimes it is going to the maximum 150 and another is the also near about the 200. So we can't see in this data anymore, but if I plot in this data like this, applying the CF and PACF, so look here, just I could here need the differentiation. So first I can get data dot dff differentiation dot drop on, and ax will equal to data dot plot and ax dot set underscore y level and plt we could plot here. This is the differentiation in this data. And we have plotted, but I am not getting anything just here. Applying of and the ADF test like a difference data. So from the stats model TSA, just I have already plotted a stat tools input the AD Fuller's Dickey Fuller test and result the Dickey Fuller data and p value results if the p value is lesser than 0.05 and print stationary because 5%, 10% and else not stationary. So you can check your data what I'm doing. So you could see here, yeah, your data is stationary. So I hope it's clear, your data is stationary. So if Dickey Fuller test or differentiation test, and if this data is need to the stationary, so you could understand just look like a means if you want to be like a sure that, so there is the more use to the PACF for and just selecting the best theoretical lag. So now the plotting autocorrelations functions and the partial autocorrelation functions. So let's start models dot graphics dot TSA plot import plot underscore ACF plot underscore PACF plot underscore ACF data lag 20 and plot underscore PACF data lag 20 plot and so let's see your data look like this. This is the PACF and this is the PACF and this is the ACF. Above is the autocorrelations and below you can see the partial autocorrelations. So moving average ACF plot and many value of almost look like a zeros. Most of the time you can see the your value 1, 2, okay, or zeros and few spikes like a 1, 2, 3, 4, 5, 6, only few are the spikes. Similarly, you could see here like a partial autocorrelations. It's a similar. Okay, so PACF and ACF could be similar. So let us now apply to end some example like a data that you will use. For the examples are like Reliance stock, closing price stocks, and this data I have already plotted. And one more thing, just if you can see like a upward trend, so it is not even the necessary to apply the ADF test here to see that this data is not a stationary, since MA model cannot have functions without a stationary. So just we have already find out like according to the Dickey Fuller stationary, so don't need to. So if you are confirmed like a stationary of the difference series, then we have already plotted autocorrelation functions and partial autocorrelation functions. And there is not a very clear pattern. You could see here there is no very clear pattern in the autocorrelations, not a partial autocorrelations. So then we would conform a choice for the order. So you can observe the some decay in partial autocorrelations functions, which is the positive sign for using a time series approach. You could see but nothing too obvious on the choice of lag. So let's fit the MA model with the order like a 1 and see what it does. So fit MA model in a Python, we need to use like a RIMA functions from a stats model. RIMA is a model that you will see in the next video. So it is a model that contains the multiple building blocks of univariate time series, including AR for AR model and MA for MA model. So we can specify the order for the each of the small models separately. So by setting everything exact MA to a 0, we obtained a MA model. So let's see, need to the import like a sklearn dot matrices import r square underscore score, and another is the stats model time series analysis dot RIMA model import RIMA. Now forecast the first MA1 model. Need to the write some algorithms RIMA data dot differences and parenthesis dot drop on parenthesis order we are taking like a MA, so you can put here the 001 and residue is like a model dot fit mo dot fit and original data dot differences and drop on and predicted like a RES as a predicted residuals dot predictors and PLT plot ORIG underscore data and plot predicted. So let's see what happened. I did so exactly, you can see the very well. So your original data and it's a predicted data. So this gives you a plot like a fit and R square scores on the full period. So absolutely you can understand this data. So this plot looks not too bad. So the orange curve like predicted follows and the general trend in the blue curve actual value. So we can observe that the predicted curve is less extreme in its predictions. The higher are less high and lows are less low. So R square score you could see here like 48 approx, you can see like a 49. Okay, 49. So in an interpretations we could observe that there is an underfit in this model. It does capture the basics, but it does not capture enough of the trend to be a very good model. So at this stage we can already have like a check it's the out of sample performance by creating a train and test sets. So let's try here. So I tried like a training. So sometimes a forecaster can believe and they are going with this data, but it's not a good. So the fitting the MA model on the train data and evaluating the R square on the train and test. So let's the training this data like data dot differences and drop on. We will start from the 0 to 240 and testing for the data like 240 to 250. We can take according to your, because if you have a like a 800 rows, so according to you can collect your data according to you. So like the mode ARIMA train order like a ARIMA model and mode dot fit and ORIG data dot differ and drop on all are the same, just previous I have written the same residuals like a predict and forecast and residual forecast steps length like a test and print R square and another print R square. One is the train, another is test. So after this forecast I see here, look like here there are two forecasting. So I hope you could see two value. One is the 46, another is 808.08. So first is the like a training data R square and another is the testing data R square. So what is the meaning in this data? So this should give uh, us like a train R square of like a 46 and test R square of approx you can say 0.8 like a 8% and 9%. This performance on the training data is not good and performance on the test data is even worst. Only 9% of variations in the test data can be explained by the MA model. So it's a very difficult, so it's a visual of the test data actually, whereas the forecast should confirm this bad fit. So let's see, I want to see like a plotting the out of sample forecast MA1 and with the order one. So let's see. Yeah, now I am plotting this data. So out of the sample forecast, the MA model, and you will see the plot like a test and another is the forecast, and plot the legend like a actual price and predicted price. So you could see here this is the predicted price like a constant and actual price is moving upward. So out of the sample performance of the MA1 model, but when we look at this visual, we can see that there is something weird going on with the forecast on the test set. So MA1 forecast has a forecasted the average for the every value except for the first steps into the future. So, and there is a mathematical reason for this. MAQ model use the model error of the past Q steps to predict the future. So when predicting one steps into the future, there is no problem in this data. So the model has the actual values and the fitted model of the each time steps before the predictions. But when doing a forecast for the second steps, the model does not know the actual value for like a t plus 1, while this is an input and this is needed for forecast like a t2 t plus 2. So like this is called multi-steps forecasting with a model retraining. So just we have already discussed like a forecast was made of like a 10 steps forwarded, like in the previous video. It no attention has it been like a paid to an essential differences in a forecasting. But this is the difference between the one step forecasting and the multiple steps forecasting. So one step forecasting is the basis. It is a relatively easy to the predict the one step forward. Multiple step forecasting is not an easy task and using a time series as errors will accumulated with every steps forwarded you take. So now the many cases I have seen, the most of the accurate solutions is to retrain the model each time steps. So in fact it is possible to do this if you update the model as soon as you obtain a new data point. This means that we would to repeat one steps forecasts. So the some cases this can work, and while the other cases it necessary to the forecast further in the futures. And one is the most important to the consider the durations if you are forecast in the model evaluations. If you do multi-step forecast, you should do the evaluate on the multi-step train test split. If you do one step forecast, you should do the evaluate on a one step train test split. So if you do one step forecast, you will find yourself in a lack of the test data sets. So you cannot compute a predictions error on the test data of one data point only. So let's see the we will see here like MA1. So you could see like the estimating the error MA1 for the 10 repeated the one step forecast. So let's see the one step forecast. So imported pandas and train test differences drop on 0 to 240 and test like data dot differences dot drop on like a 240 to 250. Import the ARIMA model from stats model. I have already discussed this model, and I am using here like a forecast and for steps in a range length test. Forecast the first MA model mode ARIMA train dot rest underscore index drop will equal to true order like a this is the 001 and the residuals mode dot fit parenthesis origin underscore data dot differences drop on and predictions residues the predict here forecasting like a plus equal to list residuals and forecast steps will equal to 1. So one step there is no need, it will take a train and train dot appends pd dot series test steps and print r square underscore list like a test and forecast, and then we can plot list test and plot forecast, and we could see here the actual and predictions. So it's all right. So this is the actual and this is the predicted. So what do we see here? So estimate the error of the MA1 model for the, so you could see R square scores you obtain like using 60%, yeah, 60. So it's not a perfect, but in this starts look like something useful. So the graph is forecasted the value whereas the actual you can see, and you can easily forecast like a one steps more. So this is the best way, and you could see here your forecasted is really good, and forecasting the one step multiple times, it's a relatively acceptable forecast. So of course error, the estimates of that we obtain in this way is the only the error estimates for the forecast of the next time steps, and now this will not be valid for the longer period. So this is the basic examples and try to understand. So this will be the specific example we can consider, that if we can predict the perfectly predict the stock market of the next day, this is already the quite the accomplishment, and let us retain these one step errors for this case. And we can create like a grid search and to find the best MA model, but need to take a more time, because if you go here like a grid search, so your laptop will sometime hanging and it should take a more CPU. Okay, so it is a possible you can do here, you can use here the GPU. Okay, but this is your forecast. I think it will be the helpful for everyone. So this one is the MA models, okay, forecastings. Thank you very much.